A magnitude 4.7 earthquake just tore through Italy's supervolcano, the strongest tremor this system has produced in roughly 40 years, and it happened directly above a chamber of molten rock sitting beneath one of the most densely populated volcanic regions on Earth. This is Campi Flegrei, just west of Naples, around the town of Pozzuoli. On the evening of July 31st, 2026, at 7:46 p.m. local time, the ground let go with a shallow magnitude 4.7 quake, centered only about 3 kilometers underground. That shallow depth is exactly what made it so destructive, despite a magnitude that would barely register as newsworthy almost anywhere else in the world. Power lines came down. A high-voltage pylon supplying P-Art of Naples collapsed. Train and metro service across the region was suspended as a precaution, and a hillside gave way in the Girolamo area, Seninu. G-boulders crashing down onto parked cars in a cloud of white dust, crushing at least 2 vehicles that were fortunately unoccupied at the time. Several people were injured, reportedly around 8 in total, though official CL classified those injuries as non-life-threatening. Local officials called it the strongest quake to hit the area since the current unrest began, and multiple outlets are describing it as the strongest tremor the region has felt in roughly 4 decades. Resident S in Pozzuoli, Bagnoli, and parts of western Naples poured into the streets as the shaking continued, and reports from the nearby islands of Ischia and Protaida describe the tremor being distinctly felt there as well beyond the immediate epicenter. Let's talk about why a single 4.7 earthquake at this specific location deserves genuine attention, because the story here isn't really about one earthquake. It's about what that earthquake represents inside a much longer, still unfolding pattern that has been building for years. Campi Flegrei isn't a mountain in the way people usually picture a volcano. It's a caldera, a vast collapsed crater roughly 12 to 13 kilometers across, so large that much of it sits directly underneath the town of Pozzuoli and the western edge of Naples itself, invisible to residents going about daily life on top of it, since there's no looming peak to serve as a visual reminder of what lie beneath their feet. Italian volcanologists themselves classify it as a supervolcano in their own published research, not just in dramatic online commentary. It has produced genuinely enormous eruptions in its deep history, including the Campanian Ignebrite eruption around 40,000 years ago, one of the largest volcanic events in European history, spreading ash across a huge swath of the continent and possibly contributing to climate disruption at the time, and the Neapolitan Yellow Tuff eruption roughly 15,000 years ago, which itself formed much of the visible landscape and rock structure people see around Naples today. Its most recent eruption, a comparatively small event called Monte Nuovo, happened back in 1538, nearly 500 years ago, building an entirely new small mountain in the space of about a week and displacing local residents at the time. It hasn't erupted since. But this isn't a sleeping static place doing nothing in the intervening centuries. It's defined by a phenomenon called bradyseism, the slow, ongoing rise and fall of the ground itself as an enormous hydrothermal and magmatic system beneath it inflates and deflates over years and decades, occasionally visible to the naked eye in things like the position of ancient Roman columns at the nearby archaeological site of Serapeo, which show clear evidence of having once been partially submerged underwater before the ground rose again. That inflation is exactly what has been driving the current unrest since around 2005, then accelerating sharply after 2020. Campi Flegrei has been steadily rising via ice, venting more gas and generating more earthquakes than it had in decades of comparatively quiet monitoring beforehand. As of monitoring data from earlier this year, cumulative ground uplift at the center of the caldera has now passed 1 meter. Since this current episode of unrest began, a genuinely significant amount of deformation for a system like this, roughly comparable to the total uplift recorded during the entire well-known crisis of the early 1980s, but sustained and building over a considerably longer stretch of time this time around. Italy's National Institute of Geophysics and Volcanology, known as INGV, tracks all of this in extraordinary detail using a dense local seismic network, continuous GPS ground stations positioned across the caldera, and gas monitoring equipment stationed at the Solfatara crater, where sulfurous fumaroles vent constantly and the ground itself is visibly, audibly alive, bubbling mud pools and hissing steam vents that have made the site a tourist attraction for Senti. Uri's, even as it doubles as a genuine scientific monitoring station today. The past 2 years in particular have been unusually active by any historical standard for this specific volcanic system. 2025 was already a record year for earthquake activity here, including a magnitude 4.6 in June of that year and another magnitude 4.6 back in March, both notable events in the ME, air own right before this latest quake. Then on July 31st, 2026, this new magnitude 4.7 became the strongest event of the current unrest episode, arriving after more than 90 additional smaller earthquakes were recorded in the surrounding hours, forming what seismologists call a swarm, a tightly clustered burst of seismic activity concentrated in both time and location. Seismologists measure not just the raw count of these earthquakes, but the total energy they release, and by that measure, this single 4.7 quake reportedly released more cumulative seismic energy than an entire prior swarm of roughly 1,000 smaller tremors combined, since earthquake energy scales dramatically. With magnitude, rather than growing in a simple straight line, a magnitude 4.7 releases something on the order of 3 times more energy than a 4.4. And that kind of exponential scaling is exactly why seismologists pay disproportionate attention to the single largest event in any sequence, rather than simply counting how many tremors occurred. So what's actually driving all of this underground? To understand that, it helps to understand what geologists believe is sitting beneath the surface based on decades of accumulated survey data rather than guesswork. Campi Flegrei doesn't appear to have one simple giant open tank of liquid magma, the way older popular imagery and disaster documentaries tend to suggest. Modern Geophysica L surveys, using both seismic imaging, essentially listening to how earthquake waves bounce and bend as they pass through different underground materials, and resistivity measurement, as that map how electrical current moves through different rock types underground, have identified what researchers describe as a cap rock layer sitting above the deeper magmatic system. This cap is essentially what's currently holding pressure back while hot fluids, gases, and superheated water push up against it from below. W, gradually fracturing it further over time with each new pulse of pressure. Much of what's actually driving the shallow earthquakes in the top few kilometers appears to be linked heavily to this hydrothermal system. Superheated fluid and gas working their way through networks of tiny fractures in the rock, rather than a straightforward direct injection of fresh magma into the shallow crust the way some coverage tends to imply. That distinction matters enormously for how researchers interpret each new earthquake swarm, since hydrothermal-driven seismicity and magma-driven seismicity can behave quite differently over time and carry different implications for what might happen next. Deeper down, the actual magmatic system beneath Campi Flegrei is understood today less as a simple underground lake and more as what geologists call a mush zone, a body of rock that's mostly solid crystal structure, with pockets of liquid melt distributed through the gaps between those crystals. Picture something close, or to wet sand than an open swimming pool, material that holds its shape and resists sudden movement rather than sloshing freely the way a true liquid reservoir would. These systems also commonly include separate magma lenses, sills, and dikes at various depths, rather than one single unified chamber, thin, distinct pockets and sheets of partially molten rock scattered through the surrounding solid crust. T, which makes the overall plumbing considerably more complex to model and predict than older textbook diagrams suggested, and which is exactly why modern research has moved decisively away from the simple single-chamber picture that dominated public understanding of volcanoes for so long. Now here's the genuinely important and genuinely uncertain part of this story. Researchers who study Campi Flegrei closely have been watching a broader pattern develop over years, not just reacting to any single earthquake in isolation. Some point to deeper seismic activity across the wider Campanian Volcanic A, RC, the tectonic region running through this part of southern Italy, where the African plate is slowly subducting beneath the Eurasian plate, the same broader system responsible for Mount Vesuvius sitting nearby, the volcano infamous for destroying Pompeii in 79 AD, Mount Etna in Sicily, currently one of the most consistently of Naples around 375 kilometers down, an unusually deep event for this area that researchers still don't fully understand the mechanism behind, since deep focus earthquakes at that depth don't follow the same simple fault rupture rules that shallow earthquakes do, and instead likely involve mineral phase transition, NS, or other exotic processes happening under extreme pressure and temperature far beneath the crust. Whether or not that deep event is meaningfully connected to the shallow unrest at Campi Flegrei remains a genuinely open scientific question. And responsible researchers are careful not to claim a firm causal link without considerably more supporting data than currently exists. It's worth being clear about what this region has already survived and continues to live alongside day to day, because the human context here matters as much as the geology. Naples is one of the oldest continuously inhabited urban areas in Europe, and its relationship with this volcanic landscape stretches back thousands of years through Greek and Roman settlement, medieval periods, and into the present day. This isn't a remote, uninhabited hazard zone that people simply choose to avoid. It's dense, historic, working city neighborhoods, ancient Roman ruins, working ports, and modern infrastructure all sitting directly on top of an active caldera that has never stopped breathing beneath them. What's not remotely in question is the human stakes involved here. Somewhere between hundreds of thousands and roughly 1 million people live across the Campiflagré area today, depending on exactly how you draw the boundary of the caldera and its surrounding zone, making it one of the most densely populated volcanic hazard areas anywhere on the planet, far more so than most other calderas capable of a comparable eruption. There's currently no evacuation order in place, and Italian civil protection authorities continue to monitor the situation closely through their established alert level system, which has been raised in stages over recent years as unrest has intensified, moving from green to yellow alert status some years back without yet reaching the highest level reserved for a judged imminent eruption. Families in this region have lived through cycles of Brady seismic unrest before, including a notable episode back in the early 1980s that caused real concern at the time, produced its own significant earthquake swarms, and led to a partial, temporary evacuation of part of Pozzuoli, affecting thousands of residents who were relocated to newly built housing while officials assessed the risk. What researchers are consistently emphasizing now is that the current episode, running since roughly 2005 and accelerating sharply since 2020, has already substantially exceeded that 1980s crisis in scale, duration, and cumulative ground deformation, even though the 1980s episode is the one most older residents still remember most vividly and compare every new development against. So, does any of this mean an eruption is coming soon? Here, the honest, responsible answer has to be layered carefully, because oversimplifying it in either direction does a real disservice to people actually living there and trying to make sensible decisions about their own lives. A single magnitude, 4.7 earthquake, even a genuinely destructive one, doesn't by itself indicate an eruption is imminent within days or weeks, and no credible volcanologist studying the system is currently making that specific claim. Large calderas like this one operate on timescales that can stretch across years or decades of building unrest before anything resembling an eruption actually occurs, and it's entirely possible for episodes of intensifying seismicity and ground uplift to eventually plateau and quiet back down without ever reaching an eruptive event at all, sometimes for reasons that only become fully clear well after the fact. Campiflagré's own history includes exactly that pattern. Periods of serious unrest in past centuries and even earlier in the 20th century that ultimately subsided without eruption, leaving behind only the geological and historical record for later researchers to study. At the same time, downplaying what's happening here would be equally dishonest and would do a disservice to the seriousness with which local scientists are treating it. The trend since 2020 genuinely is exceptional by the standards of this system's own recorded history and the physical infrastructure holding the deeper prizes. Shurback, that caprock layer identified through seismic and resistivity surveys, does appear to be undergoing real, measurable fracturing over time, based on the pattern of repeated earthquake energy concentrating in progressively shallower depths across recent bursts of activity. Volcanic systems generally don't simply escalate in a straight line toward eruption and nothing else, either way a countdown clock might. They tend to move through cycles, a period of stress loading as pressure builds, followed by periods of partial release through smaller earthquakes and gas venting that ease some of that pressure, followed by renewed loading as the underlying system continues supplying heat and fluid from below. Whether the current pattern at Campifel, Agré represents one more cycle in a long-running, ultimately survivable process, similar in kind if not in scale to what happened in the 1980s, or represents a genuine step toward a future eruption that this specific cycle won't fully reverse, isn't something current science can definitively answer in advances. With the tools available today. Nobody has directly observed this particular caldera complete a full eruptive buildup using modern monitoring instruments, since the last eruption predates essentially all of today's scientific tools by nearly 500 years, meaning researchers are, in a real sense, watching something genuinely unprecedented in the era of instrumental science. What genuinely would represent an escalation worth watching closely, according to the monitoring community's own stated benchmarks, isn't one strong earthquake in isolation, but a sustained, tightly clustered sequence. Repeated magnitude 4 or higher events happening close together over a period of days to weeks rather than months or years apart, accompanied by rapidly accelerating ground uplift, well beyond the current steady rate of roughly 10 millimeters per month, and significant sudden shifts in gas emissions or fumarole temperature at Solfatara that depart clearly from the long-term baseline researchers have been tracking there for years. That specific combination hasn't yet occurred here, at least not based on everything currently visible in the public monitoring data. What has occurred is a single genuinely severe earthquake sitting at the upper end of what the system has produced during the entire current episode of unrest, following an unmistakable multi-year trend of increasing seismic energy, gas output, and ground deformation that long predates this particular event by years. Researchers are treating it as exactly that, a serious data point demanding continued close monitoring and careful public communication, not a confirmed countdown to any specific eruption date, and not something to be dismissed as routine background noise either. It's worth remembering, too, that supervolcanoes on this scale simply don't behave like smaller, more familiar volcanoes such as Vesuvius or Etna, where the connection between rising unrest and an eventual eruption tends to be somewhat more directly traceable through historical precedent. Campi Flegre's last eruption in 1538 remains the only eruption from this specific system that anyone has ever directly witnessed and recorded in writing. And even that event, while genuinely dramatic at the time, building an entirely new hill within about a week, was tiny by comparison to the truly enormous eruptions this caldera produced tens of thousands of years earlier. That leaves researchers working with a genuinely limited historical dataset for calibrating exactly what a modern buildup towards something larger would actually look like in real time, using instruments that simply didn't exist the last time the system erupted at all. There's also a real practical secondary risk worth understanding here, separate from the question of a major eruption entirely, and arguably more relevant to daily life for most residents in the near term. Campi Flegre's hydrothermal system has already caused smaller localized problems even without any dramatic eruption taking place. Earlier this year, a fumarole vent opened unexpectedly and released gas into a school building nearby, forcing a temporary closure while the area was assessed and ventilated safely. A genuinely alarming incident for the families involved, even though it stayed well short of any larger catastrophe. Shifts in underground gas pathways, sudden changes in groundwater behavior following significant earthquakes, including reports elsewhere of dormant wells and springs suddenly flowing again after major seismic events, and continued structural damage to older buildings. From repeated shaking are all genuine near-term concerns for residents, independent of whatever the deep, long-term volcanic risk, ultima, turns out to be. A magnitude 5 or higher earthquake, should one occur at similarly shallow depth to this latest event, could cause considerably more structural damage across a densely built, historically old urban area than this 4.7 already did, given how much the local building stock predates modern seismic building codes by decades or even centuries. Researchers monitoring the trend do consider a magnitude 5 class event to be a realistic possibility if current activity keeps climbing at anything like its recent pace, and some have specifically noted that a strong 4.7 like this one could plausibly function as a precursor event ahead of something larger, though that remains a possibility rather than a confirmed prediction. It's worth understanding how Italian authorities translate this monitoring data into real-world decisions, because that process is itself part of the story. The alert level system isn't a single dramatic switch that flips from calm to catastrophe. It moves through defined stages: green for baseline monitoring, yellow for closer attention, orange for heightened concern, and red reserved for a judged imminent eruption, with each transition based on seismicity, ground deformation, and gas chemistry crossing predefined thresholds rather than any single dramatic event. The system currently sits at yellow, where it has remained for years, even as individual earthquakes have grown larger, which tells you something important. Authorities are treating this as a continuation of an already elevated state of vigilance rather than a sudden new development requiring reclassification, a deliberate technical process rather than a reactive one driven by any single headline event. It's also worth noting how unusual Campi Flegre's monitoring density actually is by global standards. Very few volcanic systems anywhere are watched this closely by this many overlapping methods: dense local seismometers, continuous GPS tracking sub-centimeter ground movement, satellite radar interferometry, measuring uplift across the entire caldera, and gassate. Hempling stations at Solfatara feeding data in near real time mean that if this system does move towards something more serious, the odds of catching meaningful precursor signals are considerably better here than almost anywhere else facing a comparable hazard. That's a genuine point of reassurance, even as it doesn't resolve the underlying uncertainty about where this episode ultimately ends up. There's a broader pattern worth mentioning too, without overstating it. This isn't the only part of Italy showing notable activity recently. Mount Etna, further south in Sicily, remains one of the most consistently active volcanoes on the planet, with its own recent ash and lava activity entirely independent of Campi Flegrei. Marsili, the large Betis submarine volcano in the Tyrrhenian Sea, remains a subject of ongoing interest precisely because it's so poorly studied relative to its size. None of this means these systems are mechanically linked. Italy sits along a complicated tectonic boundary where the African and Eurasian plates interact, which naturally produces multiple active systems in relative proximity, each on its own independent timeline, without any single shared trigger connecting them. For residents and anyone following this from further away, the most useful thing to watch going forward isn't any single new earthquake number, but the shape of the ongoing pattern. Is the rate of magnitude 4+ events accelerating beyond an already unusual couple of years, or settling back toward baseline? Is ground uplift continuing at its recent pace, or iacally, and being noticeably faster than the roughly 10 millimeters per month that's defined this episode? Are gas emissions and fumarole temperatures at Solfatara staying within their established range, or shifting in ways that depart clearly from years of tracked baseline data? Those three threads together, rather than any one in isolation, are what INGV and the broader scientific community are actually using to judge whether Stil didn't do. His remains part of a long, unresolved cycle, or is tipping towards something genuinely new. Nothing currently public says that tip has happened. What's clear right now is that the underlying trend hasn't reversed course in any meaningful way. And this particular earthquake is now permanently part of the record that any future scientific assessment will have to weigh carefully alongside everything that came before it. Campi Flegrei is a genuine, scientifically classified supervolcano occurring. I am tilly going through its most significant episode of unrest in at least 4 decades, and quite possibly the most significant in its instrumentally recorded history, stretching back over a century. A magnitude 4.7 earthquake, the strongest of this entire episode, just struck at extremely shallow depth directly above its main hydrothermal system, causing real, so far contained, damage and injuries across Pozzuoli and parts of western Naples. The underlying cause appears to be a combination of hydrothermal fluid pressure and deeper magmatic processes, gradually fracturing a cap rock layer that has been holding the system's deeper pressure in check for centuries. None of that translates into a confirmed timeline for an eruption, and researchers studying the site are explicit that this remains fundamentally a low probability, high consequence risk, rather than an imminent certainty. The kind of scenario where the potential severity, if it did happen, is enormous, but the actual odds of it happening on any given day or month remain genuinely small. But it also isn't nothing, and it isn't a story that resolves neatly with easy reassurance either. It's an active, still unfolding scientific situation, sitting directly underneath a heavily populated modern city, one with millennia of continuous human history layered on top of it, being tracked in real time by some of the most detailed volcanic monitoring infrastructure anywhere. We're on Earth, infrastructure built specifically because Italian scientists have long understood exactly how much is riding on getting this right. The honest answer to what happens next is that nobody, including the scientists watching it most closely with access to the best available data, currently knows for certain. What they do know, and what they're consistently and carefully communicating to the public through offices, AL channels, is that the underlying trend has been moving in one direction for 6 years running, gradually accelerating rather than settling down. This earthquake didn't reverse that trend, and it offered no clear sign whatsoever that the underlying pressure is easing. If anything, it only confirmed that the overall trend is continuing and possibly even picking up pace, which is exactly why monitoring teams across the wider region are treating the days and weeks directly ahead as a genuinely important window for understanding where all of this actually goes next.